पिक्सल्स आ गए, डिस्टेंस बिटवीन पिक्सल रिमेन्स सेम, वही ग्रिड है, उसी तरह की ग्रिड है, बट दिस टाइम देयर आर 750 पिक्सल्स। समझ रहे हो बात को? ठीक है, एंड सो ऑन, लेट अस से this is the last row of pixels. So 0 to 749, that is 750, and similarly column number 0 to 749, this is the 749th column, last. And similarly here. Now question is that you have increased the number of pixels here. If suppose there is an image here, यहां पर कुछ इमेज है ना, ये मान लो इमेज है, क्या कैसी बना दूंगा, ठीक है ना, ये इमेज है, ठीक है ना। नाउ दिस इज टू बी जूम्ड। अब तुम मुझे बताओ कि कैसे, मतलब व्हाट डू यू थिंक, ये पिक्सल जो है कंप्लीट पिक्सल, ये ब्लैक है, ये पिक्सल भी ब्लैक है, जहां जहां ये है ना कंप्लीट पिक्सल है, ये भी मान लो कि है, और ये है, ये वाला पिक्सल जो है ऑक्यूपाइड है। ऑक्यूपाइड का मतलब ये है कि दे आर हैविंग सर्टेन इंटेंसिटी वैल्यू, है ना, दे आर हैविंग सर्टेन इंटेंसिटी वैल्यू। अदर पिक्सल्स आर ब्लैक, लेट अस से, और व्हाइट, डजंट मैटर, ठीक है ना। बट दीज पिक्सल्स व्हिच आई एम शोइंग यू, दे आर हैविंग सर्टेन intensity, gray level intensity value between 0 to 255. Each of these pixel is having an intensity value, some value between 0 and 255. That you understand now. ठीक है ना, किस पिक्सल का क्या शेड होगा, that depends how much gray it is. Okay. Now my question is that in the new image, which will be a zoomed image, how I should assign the value of intensity? भाई zoomed image बनानी है ना, so that means every pixel here in the new image has to be assigned an intensity value, है ना। Suppose I ask you, what is the intensity value of this pixel? How will you find out? बात समझ में आ रही है? What is the problem? ठीक है ना। So because from the old intensity value you have to bring new intensity value which is not present in the new image, calculation करनी है आपने, you have to make calculations, then only the new intensity value will come. That's why this is called an interpolation problem. भाई interpolation का meaning क्या है? Interpolation का meaning ये है, for example, suppose there is a straight line. Now on the straight line, these points are lying on the straight line. ठीक है ना? I want to find out whether this point is lying on the straight line or not. This is the point. This is x-axis. This is y-axis. Whether this point is lying on the straight line or not. Actually, you have to extend this line in order to see this point. Because originally line was whose location, whose properties are not known, whether it is lying on the straight line or not. In order to find out that, you have to extend this line. And then you have to see whether it is lying or not. ये जो extension है ना, that is interpolation of the, interpolate कर दिया. So new points will come on the straight line. So this calculation of new points is called interpolation. Now I can say that this is also lying, this is also lying, this fellow is not lying. All those things I can tell. वो यहाँ पे same thing I'm talking in this new image. I have to calculate the intensity of this particular pixel. What intensity I should assign, what value I should assign between 0 to 255 to this pixel. ये कैसे करोगे? तभी तो न्यू zoomed image ऐसे बनेगी ना, तभी तो zoomed image ऐसे बनेगी, ये वाली जो ये बनाई थी तुमने, ये जो बनाई थी. So that means the new pixels, what value they are to us, at what intensity value they are having, that has to be told. So इसके लिए there are three methods which I was telling you. There are three methods. What are the three methods? ये first is the nearest neighborhood interpolation method. Okay. Now let me explain you what is this method. Image 750 by 750. You imagine that I am reducing the dimensions of this image. I am reducing the dimensions of this image. And I am making it 500 by 500. So that means what I am doing is that I have reduced it to 500 by 500. Let us say this is my 500 by 500 image. Naturally, when you are reducing the whole image, then whatever was the size of a pixel, whether you call it pixel, whether you call it grid, it doesn't matter. We can call it grid also. Same thing है भाई, एक ही बात है, ठीक है ना? Whatever was the size of the grid earlier, now the size of the grid will become lesser, isn't it? सोच के देखो. This dimension was, let us say, 2 centimeter. 2 centimeter. You are trying to make this as 3 centimeter so that it is zoomed. Right? What I am saying is that you reduce the whole image into 2 centimeter. Yaar, what I am saying is that you reduce this 200, this 3 centimeters length or width of the image to 2 centimeter. In this process, naturally, the grid size, the size of the pixel, individual pixel, which was something, now that will reduce, the new size will become lesser. आपके पिक्सल का साइज ये रह गया. Again, I am telling you, this was the original size. I am making a single pixel. This was the size of the pixel originally. When I have reduced it, this is the size of the pixel now. This is what I am saying. Agreed? And then when you do this for every pixel of the image, then your image will become 2 centimeter by 2 centimeter. इसमें तो कोई डाउट ही नहीं है. मैंने 3 सेंटीमीटर को 2 सेंटीमीटर किया है, तो by this ratio I reduce the length and width of the each pixel. तो naturally overall pixel मेरी 2 सेंटीमीटर by 2 सेंटीमीटर हो जाएगी. हो गई वो. When it becomes 2 centimeter by 2 centimeter, then you overlap that image over the original image. Overlap old image, overlap new image over old image, overlap new image over the old image. So that means now I am having this sort of thing. This is one pixel. This is another pixel. This is the third pixel of the new image, new grid. बात समझ में आई या नहीं आई? थोड़ी. And then once you have overlapped, then assign the intensity of this new pixel. जो रेड पिक्सल है उसको इंटेंसिटी असाइन करनी थी ना, तो मैंने कैसे असाइन की? You look at the nearest pixel in the bottom image, old image. if the old image was having an intensity value, let us say 150 below this, then I'll assign the intensity of this pixel as 150. Similarly, you come to the next pixel. See, what I'm saying is that key, the old image is below, and above that you have the new grid. The red one is above and the blue one is below. And what I'm saying is that whatever intensity you want to assign to the new pixel, you just look at the nearest blue image pixel which is nearest to it, and whatever was the intensity of that pixel, old image pixel, you assign the same intensity to this new pixel. Keep doing it. You have to find the nearest to the new pixel, whichever it is. ठीक है ना? That way, definitely, some intensity will be assigned to each pixel, new pixel. Don't you agree with me? That can you imagine it? What I am saying? बताओ, is there any problem in understanding? Otherwise, I'll explain again. So that way, you will have new intensity. You will have the intensity value assigned to each new pixel. And then once it is assigned, you expand the pixel back. In fact, you have reduced the size. Now you again expand it. Make it 750 by 750 size, the same size of each pixel. Now the new image will appear. बोलो क्या problem है? Every pixel is having some intensity now. Don't worry about the distortion, etc. How much it is resembling the old image, don't worry about that. Naturally, in this process, some aberrations will come. In fact, if there was a straight line on the image before, now in the new image, might be that that straight line doesn't remain straight. It becomes like this. But in any case, the image will be formed by this method. So this is called nearest neighborhood method. You don't need to do anything extra other than, now I'll explain you bilinear interpolation. In case of bilinear interpolation, you have to do, first part is same. That means, suppose you want to zoom an image from 500 into 500 to 750 into 750. You want to make it bigger. So therefore, you do the same thing. Okay, this is the new grid now. Again, reduce the grid. Make it from 3 centimeter to 2 centimeter, the size of the image. You reduce, and correspondingly, all the pixels will be reduced in size. Okay, they will be, each pixel will be now lesser than the size of the original pixel, definitely. ठीक है ना? So you reduce the size, again you overlap it over the previous image. Now in this case, take the new pixel, you have to assign the intensity to the new pixel. You see which 4 pixels this time, 4 pixels of the old image are nearest to that new pixel. Are you getting me? Once again, I am repeating. Suppose this is the new pixel. Okay, and just see, एक मिनट, मैं इसको ये कहना चाह रहा हूं आपको कि this is the new pixel and this is smaller than the pixel of the original. So original image के ऊपर ऐसे कुछ आएगा. एक पिक्सल ओरिजिनल इमेज का ये रहा, एक पिक्सल ये रहा, एक पिक्सल कहीं यहाँ है, एक पिक्सल यहाँ है, and so on. These are the pixels of the original image. ऐसे. Are you getting me? So what I'm saying is कि जो न्यू रेड पिक्सल दिख रहा है आपको, you find out which 4 old pixels are nearest to it. So as you can see, suppose this pixel, original pixel, this original pixel, and this original pixel are nearest to it. ठीक है ना? तो you have noted down the intensity of these 4 pixels. You have noted down the coordinates of these 4 pixels. भाई इनके coordinates होंगे कि नहीं कुछ? इसको 0 0 मानते हुए ये 0 0 है. Top left is always taken as 0 0. So these 4 pixels will have certain coordinates associated with them. कुछ हर एक का कोई xy होगा कि नहीं होगा? So you have noted down x1 y1, x2 y2, x3 y3, x3 y3, x4 y4. 4 pixels nearest to the new pixel to which you want to assign the intensity. And then whatever is the intensity of this, let us say this is V1, the intensity of this is V2, the intensity of this is V3, the intensity of this is V4. Okay, so 4 locations, 4 pixel locations, 4 intensity values. You have noted down. Then what you do is, this is an equation. ये एक equation है आपके पास. Just look at this equation. V equal to ax plus by plus cxy plus d. In this equation, a, b, c and d, these are some constants. And these constants are to be evaluated. I want to evaluate these constants. Okay. After that, I'll tell you how to find the intensity of the new pixel. But these suppose constants are to be evaluated first. So for that, I told you that you have noted down x1, y1. You put in this equation the value of x1, y1. You also put the value of v1. So that means your first equation becomes v1 equal to a times x1 plus b times y1 plus c times x1, y1 plus d. Similarly, for the second pixel, which was nearest to the new pixel, v2 equal to similar equation, v3 equal to similar equation, v4 equal to similar equation. Now you have 4 equations, 4 unknowns. By v1, v2, v3, v4, these are known. You have noted down. x1, y1 you have filled here, x2, y2 similarly here, x3, y3, x4. So therefore, there will be 4 equations in 4 unknowns. What are the unknowns? A, B, C, D. So you solve these 4 equations. Simple. It's not difficult for a computer. Simultaneous linear equations. Okay. Very easily it can solve. And you will come to know the value of A, B, C, D. Once you know the value of A, B, C, D, then the intensity of this new red pixel, which I showed you, this red pixel intensity, how that will be calculated? Again, you apply this formula. Again, apply this formula. Now the intensity V will be calculated. You know A, B, C, D, put them here. You put the coordinates of the new pixel here. You put the coordinates of XY coordinates of the new pixel in this equation. And whatever comes, whatever value of V comes, you assign that intensity to this red pixel, which was overlapping these 4 old pixels. That is to be done for all the red pixels. That means for all the pixels of the new image. And that way, each pixel of the new image will be assigned an intensity value. So that, are you understanding? ये कुछ नहीं है, सिर्फ मैथमेटिक्स है. ओके, कुछ नहीं है डिफिकल्ट. तो इस तरह से न्यू इंटेंसिटी वैल्यूज विल बी कैलकुलेटेड, एंड देन अगेन लास्ट में यू एक्सपेंड द न्यू इमेज फ्रॉम 2 सेंटीमीटर बाय 2 सेंटीमीटर टू 3 सेंटीमीटर बाय 3 सेंटीमीटर. मतलब ओके, मैथमेटिकली जस्ट 1.5 से मल्टीप्लाई कर दिया. तो पिक्सेल्स जो थे वो मतलब असाइन तो हो ही गए थे सारे पिक्सल. इमेज जो थी वो लार्ज एनलार्ज हो गई. इमेज बिकम्स एनलार्ज्ड इमेज, zoomed image. So this is called bilinear interpolation. Similar is the bicubic. Here we look at the 16 pixels which are nearest to a new red pixel. 16 old pixels will be seen. Okay, and you note down the intensity values of all the 16. Similarly, you note down the Cartesian coordinates of all the 16 pixels, and then you put an equation. This is the equation. ये non-linear है, काफी non-linear है ना? You cannot do it by hand. Manually, you cannot do it. No possibility of doing it manually. Even for a single pixel calculation, you will not be able to do it. X raised to the power I, y raised to the power j, all these things, no? When I equal to 0 to 3 and j equal to 0. So you will have 16 equations in 16 unknowns this time. जैसे bilinear के केस में there were 4 equations, 4 unknowns. This time you will have 16 constants. What are the name of the constants? A01, A00, A01, A02, and so on, on. A10, A11, A12, and on. Like that, no? There will be 16. So 16 equations, 16 unknowns. Computer will solve it to find out all these constants. And then once you have found out all the constants, 16 constants, then you have to apply this equation again for the new image pixel calculation. So that means you know the coordinates of the new pixel, xy coordinates of the new pixel. You know the coefficient, these constants, so you can calculate the intensity of the new pixel. So that is the method. Same is the method when you want to shrink an image. Same is the method. Similar, ditto. There is no difference between the principle of enlargement or principle of shrinking of an image. ठीक है ना? तो एक तो आपको ये प्रोसेस जो है समझना पड़ेगा. अगर नहीं समझे तो फिर भी what goes on in the background, every image processing algorithm is having some, every process has got an algorithm associated with it, procedure associated with it, and that procedure is coded in the whatever language, MATLAB or C or whatever, and whenever you give a command, then that procedure, that algorithm, that code runs and you get the output. That's the idea. So you can see that this is the result of interpolation. This was the image, and this image was a 128 by 128 image. This image is 120 by, actually there was an original image which was 128 by 128, and that has been zoomed to 1024 by 1024. So it is just showing the result. Original image is of course not given here, but this is the result that after nearest neighborhood, this is the result after bilinear interpolation, and after bicubic interpolation, this is the result. So that you can compare and you can yourself see that best result is obtained by bicubic interpolation. Of course, so much calculation is there, so it has to be the best. Okay, this is again from 64 by 64. 64 by 64 image has been zoomed to 1024 by 1024. So these are just as such results are given. Okay, so this is the thing. Then there is one thing called image registration. What is image registration? Image registration is this. You have to understand, again, mathematics, heavy mathematics is behind it. सारी इमेज प्रोसेसिंग में मैथमेटिक्स ही है भाई, और है क्या, ठीक है ना. इफ योर मैथमेटिक्स इज स्ट्रॉन्ग, बस समझ जाओगे सब चीजें. सो सपोज देयर इज एन इमेज, दिस इज द इमेज. ओके, नाउ this image was acquired from a camera, naturally. ठीक है ना, this image was acquired from a camera. Now, by chance, suppose the position of the camera changes slightly. Let us say the ideal position of the camera was somewhere, something. There is 1 degree rotation of the camera, only 1 degree, I am still saying. ठीक है ना, naturally, in that case, the best image will not come. Can you imagine? Best image will not be acquired if the camera is not in that position in which it is required to take the best image. So, some rotated image will come as the output from the camera. So, यहाँ पर उसको, in this diagram, he has shown the exaggerated view of the same principle, that this was the ideal image which was required. However, due to the rotation of the camera, this image was obtained on the right. ठीक है ना, ज्यादा rotate कर दिया, more than what, but in order to explain you, in order to make you understand. So now this image is available to us. This is the image which is available. From this image, how will you obtain the ideal image? This image is not what I wanted. मुझे तो ideal चाहिए. This is my requirement. What should I do? उसके लिए क्या करना है? To obtain this image from this, what is to be done? And I do not know that how much my camera got tilted. Really, my camera got tilted. That I can see from the image ki yaar, this is not the best image I want. But how much was the tilt? And even if suppose I know how much was the tilt, and what to do after that? Suppose camera was tilted by 2 degree. So what? ठीक है ना, उस 2 degree के साथ मैं गले मिल कर रोऊं? क्या करूं उसका 2 degree का? What should I do with that 2 degree information? तो आइडिया ये है कि to obtain the correct image from this geometrically distorted image, something has to be done. What is done is that on the original, on the object itself, whose image you are acquiring, certain points are marked beforehand. Can you see this point which I am encircling now? Just look at this point. Look at this point carefully on your screen. You have to slightly go forward. You have to move towards your screen in order to see these points. But you should be able to see them. There are 4 very small squares. Are they visible? These 4 small squares. white squares हैं. At least on top right, it should be visible because this black square is not complete, you know, क्योंकि उसके ऊपर small white square has come. Okay, so these are the mark points, and these points are marked on the original image before taking the image by the camera. These are called tie points. Tie points. Okay, so once these points are marked, your camera got tilted. Now this image is having the tie points image also. You can see, I think these are the tie points image. These are the tie points image. 4 points were there, and what is done is, after that, this is the calculation which has to be performed. Let us say x equal to C1V plus C2W plus C3 VW plus C4. Here C1, C2, C3, C4, and similarly in the second equation C5, C6, C7 and C8. These are constants. ठीक है ना? These are constants. And V and VW, that is the coordinate of the tie points in the input image. VW, that means this is V comma W. So that means V1 W1 is the coordinate of first tie point. V2 W2, matlab, if I show you in the image, this coordinates of this point are V1 comma W1. Coordinates of this point V2 W2. Then V3 W3 and V4 W4. Okay, these are the coordinates. These are defined. You know them. You have marked these points, so you know them where you have marked. No problem. In the image, in the acquired image, this tie point is here, and the coordinates of this tie point are x1, y1. This is x2, y2, x3, y3, x3, y3, and x4, y4. Now what you do, you note down these coordinates also, because this image is with you. ठीक है ना? Original image was also there because you have acquired the image of that object. So this object is already there with you. This is the object for us, whose image we are acquiring. This is the object. And this is the acquired image. This is the acquired image. Right? So we know all these coordinates. There is no problem. You put these coordinates here in this equation. So you will get 4 equations corresponding to this and 4 equations corresponding to this. And then you have 8 equations and 8 unknowns. 8 equations, 8 unknowns. Definitely you can solve unique solution. You can find out. So find out what are the value of the constants C1, C2 up to C8. Find out these. Once you find out these, you can apply the same equation for correcting the image. That means now you have every point of this acquired image, xy coordinates of every point you can measure. You put in this equation that value of xy. All the 8 constants are known to you. Find out VW corresponding to each xy. corresponding to each xy point on the acquired image, you find what is the value of VW. And VW belongs to the coordinates of the original image. So that way, you will be able to find out the coordinates of the original image. That is the way. This is called image registration. Okay? Did you understand? This is called image registration. From this distorted image, you are able to find out what would have been the correct image. Had you acquired this image correctly, what it would have been. So here it is shown here that after correcting this image, what we obtain is this. This is the result. Result of correction. Result of correction by this procedure, which I told you. And in order to see the difference between the original actual image and the corrected image, we have taken the difference, and this is the difference image. This is the difference image. Mostly black का मतलब क्या है? There is no difference. Wherever you can see the black, that means the difference is zero. There is no difference. Only at some places, of course, there is a difference, slight difference to some extent, depending upon the value of the, how much gray it is. So there is very small difference. So that is the way to correct an image. So image registration, I think you have understood what process is there behind image registration. Then we take the Fourier transform of an image in order to take it to the frequency domain. What are the various frequency components which are there in the image? Just like you take the Fourier transform of a signal, to find out what are the frequency components in the. आप क्या करते हो? आप Fourier transform किसी सिग्नल का, why do you take the Fourier transform of a signal? If this is the signal, ये सिग्नल है, ठीक है ना? Suppose this is xt versus t. You take the Fourier transform. फिर आप Fourier transform को प्लॉट करते हो, ठीक है ना? Fourier transform को प्लॉट करते हो. This way you have the frequency, and this way you have the Fourier transform amplitude. ठीक है ना? Fourier transform याद करो. Do you remember? So this is the Fourier transform. So whatever information signal is giving in time domain here, in this case, in Fourier transform, the information is hidden in terms of frequency. So that is another way of looking at the signal. Whatever you cannot see here on CRO, some extra thing you can see here on a spectrum analyzer. Okay, you can display this Fourier transform on a spectrum analyzer, and you can see what is the amplitude of the, let us say, 100 hertz component of the frequency. What is the amplitude of 200 hertz component of the frequency? So all the frequency components are there in the signal. You can find, just like you can find out what is the amplitude of the signal at this point of time. What is the amplitude of the signal at this point of time? Similarly, here you can see what is the amplitude of the frequency value. These are the frequency values on x-axis, and these are the amplitude of the signal at those frequencies. Okay, so frequency components you can see here. This is called Fourier spectrum. This is called Fourier spectrum. ठीक है ना? तो आइडिया ये है because all filters etc they are designed in the frequency domain, है ना, this should be the cutoff frequency of a low pass filter, or let us say high pass filter, or band pass filter, or notch filter, like that. No, you must have studied all these filters. So every time you define the in a band pass filter, you define the band of frequencies which should pass through the filter, and other frequencies should be stopped by the filter. Okay, so that means because all the filter design is based on frequency information, so therefore always we can take the signal from time domain to frequency domain. That's the idea. So that we can design the filter. And we can filter out the noise, etc. That way. So here also, your image is a two-dimensional signal. And just like a one-dimensional signal which you have studied so far in your life, image also can be taken from a space domain to frequency domain. So if you do that, that is called Fourier transform. There are so many transforms. In fact, Fourier is not the only one. There are many transforms. Okay. Wavelet transform, Hadamard transform, Walsh transform, this transform, Haar transform, so many of them. Okay. Each one has got different equation, different way of taking the signal from time domain to frequency domain. Yes. Here we don't call time domain, we call it a spatial domain. क्योंकि आपका जो है ना, all pixels are defined in the space domain. The Cartesian coordinates defined है उनके, ठीक है ना, उस पे intensity values. So therefore we say that this image is a signal in the space domain. It is equivalent to the time domain of the one-dimensional signal. It's the same thing. So only thing is that when you take the transform of a signal, then you can carry out the filtering operation. And lastly, you have to convert it back into the space domain, because human beings do not understand frequency domain. If I show you a signal in frequency domain, you will not be able to make out anything from that. You cannot make out anything. You will say what garbage it is. Because you have been taught, I'll say you have been taught in your life to look at the things in time domain or space domain. Those are the variables which are actually passing in front of your eyes. Time is passing. You can imagine it. Frequency is something which is abstract for you. Okay? You do not see the frequency in front of your eyes. That's the reason it is difficult to imagine the things in frequency domain. But then so much information is contained in a signal in frequency domain that you cannot imagine. Okay? So that human beings can understand what has happened to an image after processing in the frequency domain, we convert it back into the space domain. And that's a way to tackle a signal, to process a signal in frequency domain. Okay, like here, just see this example. This is an image in space domain corrupted by periodic noise. You can see the noise in the background. Okay, this is a periodic noise, and this particular image has got this Fourier transform. You can see the Fourier transform. There is a high intensity at the center, and then there are certain frequency components which are visible here. Okay, these are the different frequency components contained in the signal, and due to periodicity they lie on a circle. Okay, you cannot imagine this thing I told you it is difficult to imagine the frequency domain, but okay, doesn't matter. At least this Fourier transform is, let us say, you obtain from by applying the command in the MATLAB, let us say. Then You know that this particular, these points, no, which are lying on the circle, in fact, they are due to the periodic noise, which is contained in the signal, which is contained in the image. Okay. So you construct a filter for that, and this is the transfer function of the filter. This is the transfer function of the filter. All the values, all the frequency component, they are having the value 1 here and 0 here. And you multiply this Fourier transform with this. When the two are multiplied with each other, definitely this will overlap with here. This black strip will overlap here, and this will go. All these points will go away. And whatever is left, that is the pure image. You can see the pure image. We have converted it back into space domain. After filtering operation, we have converted it back into the time space domain, and you can see that how clean it has become, which was not possible in a space domain. Same thing became possible in frequency domain. So that is the beauty of frequency domain. So this is the definition of Fourier transform. It is our pure mathematical thing. You have to learn it, that's all. There is an image in the space domain which is of the size m by n. M and n, they stands for the number of rows and number of columns in the space domain. When I take the Fourier transform of this in the frequency domain, you will get again an image of same size, m by n. Like this. This was the image. This is the Fourier. So whatever was the size of this by this, same is the size here. Same is the size here. Size does not change. The same m by n. But now the frequencies, there are, in fact, this is x-axis, this is y-axis. Here, this is the frequencies denoted by V. So the signal was two-dimensional here. Signal is two-dimensional here. Okay. These are called the frequency axis. Frequency axis. Just like these are time space domain axis. These are frequency domain axis. So UV, you understand that it is in the frequency domain, it will be a function of UV. The values of different pixels, they will be a function of UV. And this is the mathematics that has to be applied. You may have to multiply the intensity of this value. This is the value of a pixel. You have to multiply it by this fellow. E raised to the power minus j 2 pi. U, you understand this is a variable, frequency variable. X, you understand what it is. M and N are constants. I told you what are M and N. So it is mathematical definition. And that way, this is your Fourier transform, TUV, which you can see. This is TUV. You will be able to see here, just like you saw it here. Okay, this was your space domain image fxy. This is the Fourier transform TUV, right? And you can convert it. You can convert any frequency domain image into space domain image. So this is the definition of inverse Fourier transform. This is Fourier transform. Fourier transform. This is inverse Fourier transform. Inverse Fourier transform. So it is all mathematical. That is what I wanted to tell you today. These are all useless things.